what's happening where it breaks up over there compared to what's happening where it breaks up at this end. Okay, so over towards the shoreline, where it's breaking up over there is quite brittle. It's breaking up into these, people call them tablets. Terms often used is chocolate tablet boudinage, because they look like pieces of chocolate get broken off. You've got a battery glass and a half full cream dairy milk. But at this end, it's quite different. If you come down here, it's basically breaking up into enclaves. And that's another way you can actually produce enclaves. So some enclaves can be formed by mingling at the margins between two distinct plutonic phases, like we saw down at Benji Point. Another way to do it is just to intrude a mafic dike and then have the dike break up. So obviously here the host is still molten, or at least partly molten, when the dike's intruded and it's been moving and the dike is broken up. Why do you think it's broken up in a brittle fashion at that end and a more plastic fashion at this end? I've already talked, so those are people I've already talked to about this. Should keep quiet. Well, it's still...
It's quenched more rapidly.
Yeah, this suggests that it was more rapid quenching at that end than it was at this end. Now, a lot of students, when they write about this, tell me that the dike was hotter at this end than it was at that end. The dike magma is the same temperature all the way along. It's the same intrusion. It's not a variation in the temperature of the dike magma. What's the variation in temperature coming from? Has to be the host. Okay, and if you look closely along here, around about where Karen's sitting just there, there's a change in composition of the host. It's subtle. If you were to pick up a piece of the tonalite from here and walk over there with it and compare the two, you would see that the tonalite that's over there is more felsic than the tonalite here. This one has a lot more enclaves in it. There's probably 20% enclave in this here, and some of them are very strongly stretched out. They've had very high flow happening here, which has probably helped breaking up the dike as well. There's enclaves here that are stretched out 50 to 1. Not all of them are 50 to 1. Pieces off the dike aren't. But what I'm getting at is that the host tonalite, it's still tonalite here, but it's a more mafic, and probably because of that hotter tonalite than the tonalite that's over there. So that at that end there, because the host has been cooler, there's been a much more rapid quenching effect than at this end. In both cases, the host has still been mobile, but because you've had full quenching of the dike magma that end, it's broken up in that more brittle fashion. And at this end, because the host has been hotter, yeah, the dike's been quenched, but it hasn't been completely solidified. So when it has broken up, it's still being able to move. It can actually still have magma motion in the dike itself, or in the fragments, and because of that, they break up in a more rounded plastic fashion. Does that make sense? Is there another question on the page? That's the main thing we get at. So we're getting at that, yep, I think there's a comment there about things aren't always as they seem, and the explanation of what's happening here is that the host is molten still. But the story's a little bit more complicated in that we've got differential temperature in the host from one end to the other. Cooler over there near the shoreline. Please don't tell me, as someone did a few years ago, that the magma over there was cooler because it was near the ocean. Remember, we're several kilometres down. There probably wasn't even any ocean here. Okay, so it's just the fact that you've got two slightly different magmas, and there's a temperature variation from there to here. Is that the only question? The key question? Have I covered the key things? Okay, now we were going to look at an outcrop about 3/4 of the way down the beach. There's a granite wall. It's actually a dike on the back of the beach, so we'll have a very quick look at that on the way back. Any questions? Any comments, David? Anglos? Alistair, no comment?
Someone's lost their answers to Ignis Petrology Lab 2. No takers?
Scrap paper.